Hey guys, happy Tuesday. Can you believe you only have to wake up one more Tuesday this year? It's crazy. Anyway, we're going to go ahead and start chapter 11 today, and we'll be working on chapter 11 for the next few days in class, and you'll be taking a chapter 11 test during our finals period. So go ahead and get out your notebook. Your substitute should have handed out the 3D graphing papers so that you can use those to help you graph today. And we'll go ahead and start talking about the 3D coordinate system. So we're looking at points in space. I think most of us would be okay with the idea of an XYZ plane or XYZ space. So notice in this drawing, your XY axis or your XY coordinate plane is now flat. It's the pink plane pictured here. X is, I think about, like, to go along with the book, X is like a forward and a backward. So forward is positive X, backward is negative X. Y is more of like a left and right movement now. So positive Y goes right, negative Y goes left. And then we form the 3D space by creating a perpendicular Z axis, and that is our up and our down movements. In addition to creating the 3D space, we've created 3 different planes that we can name. So we have the XY plane, that's pink. And then we have the XZ plane, that's yellow, formed by the x-axis and the z-axis. And we have the XY plane, or sorry, XYZ plane, that's in green, formed by the y-axis and the z-axis. And then instead of quadrants, we're going to have octants. I like to think about it like creating like rooms. So we have 4 rooms at the top and 4 rooms at the bottom. The room on the top floor, kind of facing us directly, that's octant 1. So if we're in that space, we're in octant 1. And then we're going to go counterclockwise. So octant 2 is upstairs behind octant 1. We'll go around to octant 3 in the back on the first floor, and then we come back up to octant 4 on the first floor right next to octant 1. And then this octants sort of repeat themselves in the basement. So we'll have octant 5, octant 6, octant 7 you can't see, it's underneath octant 3, and then octant 8 is underneath octant 4. And there's a page in the textbook, let me look at it real quick, page 774. Some of us, page 774, will have a harder time seeing in 3-dimensional space. So if you're struggling with that spatial reasoning, check out page 774, kind of list out the octants, and you put a little blue box where that room that I'm talking about is, so you can kind of see where each octant is. Things that you can note that will be helpful in some of your homework problems, like in order to be in a particular octant, what would the signs of your X, Y, Z ordered triple be? So if we want to be in octant 1, we're going to go forward on the x-axis, right on the y-axis, and up on the z-axis. So those are all positive movements. Versus if we want to be in octant 5, we would go forward on the x-axis, right on the y-axis, and down in the z-axis. So everything in octant 5 has a positive, positive, negative ordered triple. So we'll see some examples here in just a minute with that, and you can kind of use some reasoning in terms of movement as to where points would be. On your graphing paper, let's go ahead and graph a few 3-dimensional points. So we make sure that everybody can read this, because for some of us, we're looking at it and wondering what the heck is happening here. So we're going to model our 3-dimensional space after the method that the book uses. And this is the same 3-dimensional graph that you'll be provided on your test next week, so you can kind of get comfortable graphing on this image. So our x-axis, remember, we're going to think about x-axis as like a forwards and a backwards movement. So this line right here that I've marked, that's my positive x. And then if I were to go backwards, that would be negative x values. The other line over here, this is y. And so where I've marked y, that's in the positive y direction. Going left would be in the negative y direction. And then of course we've got our perpendicular or vertical z-axis, and that's going to be an up and a down. So I'm going to go ahead and start by plotting point A. When I plot three-dimensional points, I like to sort of leave a trail of where I've gone. It helps me visualize better where my point is in space. So if I were to plot point A, I want to go -1 on the x, so that would be back 1, +3 for y, so that would be right 3, and then +4 for z, so I'm going to go up 4. And there's where point A is. You might stop and think about, okay, in what octant or in what room is point A? That's sitting behind our octant 1 on the first floor, so that's octant 2. To plot point B, I'm going to go 2, 5, 0, so that's forward 2, right 5, up or down nothing, so there's point B. And because I didn't go up or down, I'm not officially in an octant, I'm on a plane, and I'm on that flat pink plane that we saw previously. That's our XY plane. So I can still locate that point. It's somewhere on the XY plane. For point C, I'm going to go forward 1, right 3, and up 6. And because I have all positives, that's octant 1. I'm going to give you a moment, see if you can plot D for me and name its location. Should have gone forward 2. We have a -1 for y, so we're finally going left 1, and we're still going up on z. So there's point D. I'm still up on the top floor, but since I went left 1, I'm now in octant 4. So in order to get to any of octants 5, 6, 7, or 8, I have to have a negative z value, which I don't have in any of our examples. Let's look at some additional examples. These are good things for you to think about just in terms of directions that you're moving. So I'm going to give you about a minute or so to think about, in these particular cases, in which octant or octants would you be located. So x is less than 0, y is greater than 0, z is less than 0. And then when is the product of y and z less than 0? And you can use the graphing paper to kind of like trace a point in those with those restrictions. Or if you want, you can draw your own three-dimensional space. So there's my x, here's my y, and then there's my z. That sort of helps me think about where I must be. So I'll give you about a minute, and you can talk this over with your small group, throw out some ideas, and see if you can get the right answer. Okay, I'm going to have you stop if you're still chatting. Let's see if we got these answers right. So on the first one, I'd be thinking about x is less than 0, I'm going backwards. Y is greater than 0, I'm going to the right. And then if z was less than 0, I'd be going down. So that puts me in the basement, in that back right room. That's underneath octant 2, which would match up with octant 6 down below. So octant 6 is the correct answer for that first one. For yz to be less than 0, that means it's negative, so we know that they have to have different signs. So I might first think about, okay, well, what if y was positive? Then we'd be going to the right. Okay. And in order for z to be an opposite sign, instead of positive, it needs to be negative, so I'm going down to some point. And so I'm thinking about where those points would be. The first two octants in the basement, so that would be octant 5 and octant 6 again. I could also have different signs for y and z. If y were negative, I'd be going left, and I can go forwards or backwards for x there. And then z would be positive, so I'd be going up to a point, so that puts me in octant 3 and 4. So those should be the correct answers for the second question. And you'll have some more, another opportunity to practice those on your homework. Last thing I want to talk to you real quick about is distance formula. We can find the distance between any 2 points in space. Those points in space would be ordered triples instead of ordered pairs. So one point is x sub 1, y sub 1, z sub 1, and another point is x sub 2, y sub 2, z sub 2. And as you're kind of looking at the formula, it looks long, but it's very similar to distance formula in 2 dimensions. So I'll give you a moment if you're writing that down. And then we'll do one quick example. Find the distance between the points 3, 1, 4 and 0, negative 1, 2. Plug into my distance formula. Distance equals the square root of, and basically it's 3 sets of differences squared. So the difference of my x's, 3 minus 0 squared, plus the difference of my y's, y minus negative 1 squared, plus the difference of my z's, 4 minus 2 quantity squared. If you do x sub 2 minus x sub 1, y sub 2 minus y sub 1, z sub 2 minus z sub 1, you're going to get the same answer because you're squaring the differences, so they're all going to come out to be positives. So this would be 3 squared, which is 9, plus 2 squared, which is 4, and another 2 squared, which is another 4. So then we have d equals the square root of 17. If that radical could be simplified, I should simplify it. Square root of 17 doesn't have any perfect square factors, so I can go ahead and call that my final answer. The distance between those 2 points in space would be square root 17 units. Okay. So not too bad. You're going to have the rest of the time in class to work on your homework assignment. I would guess most of you finish the assignment before the class ends. And it's page 779, numbers 9 through 31 odd, 37 and 41. It's also on your gold sheet that you have. So pull out a textbook. There are textbooks over on the shelf. Share them with each other if there are not enough textbooks to go around. And also maybe check around for your textbook at home and start bringing it back to school because we'll be turning those in at a later date. All right. Have a good time working on your homework, and I will see you tomorrow.